right, guys, last one for linear functions. We are going to do page 67, and we're going to talk about story problems, your fave, and kind of how we can solve by graphing. So that's sort of interesting. Okay, so on 67, we'll do story problems. This should be the very last one in your packet. So if we take a look there, page 67 looks like this. Now, when I went through and did each form with you guys, we talked about all the different ways that we might write a story problem. So the very first form of a line that we talked about was point slope form. Now, point slope form, in terms of a word problem, we're looking for two things, but kind of three numbers. You're going to be looking for a rate of change number, or like the slope, or an over and over and over again number. And then like one specific example of that thing happening, okay? So like this is a really good one. The train travels at a rate of 70 miles per hour. 2 hours after leaving the station, it was 210 miles from the destination. So I can tell that my rate or slope is 70. And then my one specific example is that 2 hours, I'm 210 miles away. So that's like our point, 2, 210. And then we can write it in point slope form. Now another form of our line is y'all's favorite, slope intercept. And that one is really good as a story problem when they tell me the rate of change or slope, and then they give me the starting value or the y-intercept. So like this one that we did together, an airplane with no fuel, so the starting point, weighs 2,575. And then each gallon of gas added weighs 6 pounds. So that's my over and over again number because each time I do it, I add 6, so that's slope. And then the last one that we talked about was standard form. And that was kind of the best one for story problems because they tell you A, B, and C. And like A and B were both slope numbers or rate numbers. So they give you two slopes and then they give you a total. Okay. So jumping back to this one here now, Nathan received a gift card for trading cards from a local store. The function y equals 20 minus 1.95x, oh, look at that. They already give me the equation. That's super nice. Represents the remaining dollars y on the gift card after obtaining x packages of cards. Find the zero of this function. Describe what that value means in this context. So what a zero is, it's kind of like the y-intercept, but it's just the x-intercept instead. So 0 is just a fancy name for your x-intercept. So that's all we're trying to find. And the x-intercept is at some number, comma 0, which means I'm going to figure out when I've spent all my dollars, how many packages of cards did I get? Okay, so here's our equation. When I put in 0 for y, or when I spend all my money, how many packages of cards can I get? So then we want to solve for x. So to solve for x, I want to keep x where it is and get everything away. So we'll subtract the 20 both sides. And then divide by negative 1.95. And because we're in decimal land, like it's going to be positive, but I would just use my calculator there. Like 20 divided by 1.95 is 10.3-ish. But like I can't buy 10.3-ish cards. Because like what is that? I can buy 10, which means I'm going to have a little money left over. So Nathan can buy 10 packs of cards and have change left over. I can't spend exactly all my money because they don't separate out evenly, okay? So now that I know my x-intercept is like at this 10.3-ish, I can go along the x-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my gosh, it's kind of off the graph, 10.3-ish. I can also plot my y-intercept. I'm not going to be able to get to 20 there, so let's like count by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18. Oh my gosh, 20. And I know it was 20 because that was my y-intercept right here. And then I can connect the dots. Oof. Now, all these values in between are different amounts of cards that I can buy for different money amounts over here. So the more cards that I buy, the less money I have, which makes sense. And let's try another. So Olivia wants to record her favorite songs to a USB. The function t equals 80 minus 3.22n represents the recording time t available after n songs are recorded. Find the zero of this function. Describe what this value means. Okay, so again, zero just means the x-intercept. So if it's the x-intercept, I'm going to replace y, or in this case t, with 0. Okay, so if the recording time that I have left is 0, how many n songs can I record? Okay, so again, we'll replace y with 0. And then to solve for n, we can do a lot like we did in this last one. But if you want to avoid the negatives, what I could do instead is add the 3.22n to the other side, because then that will be positive equals 80. And then divide by 3.22. And again, because I'm in decimal land, like I'll just get my calculator and divide that, but it's definitely going to be positive, and it's going to be like 24.8-ish. So who does? Olivia? Olivia can record about 24 songs with a little space left over. And again, there's a little space left over because I wasn't able to divide evenly. So, and I have to do less than 24 because I can't get 25, like 25 songs won't fit. Okay, so along the bottom here, let's put songs. And guys, because I have to go to like 24, let's maybe count by fives. So 5, 10, 15, 20. This will be 25, so we'll be almost there. And then along the side here, we have time. That's like left on our USB. And so let's count by tens because like the y-intercept is 80. So 10, 20, 30, 40, 50, 60, 80. And then we can connect the dots and we can see that as I start adding more and more songs, I have less and less time on the USB because it's negative again. And last one that we're going to do in here, Autumn uses a $20 gift card to buy coffee. The function v equals 20 minus 2.75c represents the amount of money still left on the gift card v after purchasing c cups of coffee. Now I can also see that happening in the equation because $20 is how much I start with, and every time I buy a cup of coffee, it must cost $2.75 because we're taking that off over and over and over again. Find the zero and describe what this means. So again, the zero is the x-intercept, or in this case, our v-intercept, or when I have no money left on my card, how many coffees did I buy? So 0 here. And then like the last one, I'm going to add the 275c to the other side because then it'll be positive. And then divide both sides by 275. And because we're in decimal land, I'm going to ask Miss Siri to help me there. So 20 divided by 2.75 is about 7.3-ish. So, who dis? Autumn can buy 7 cups of coffee and she'll have some money left over. Which, I mean, you don't really want to leave that on a gift card, so maybe you buy something else that's cheaper, or maybe you have to pay the difference in cash, but either way, for our purposes, that's what we got. So along the bottom, we can just count by ones. So 1, 2, 3, 4, 5, 6, 7, and a little more because it's at 7.3. And then the y-intercept is the one not on the variable, so 20. So maybe we'll count, I don't know, let's count by fours. 4, 8, 12, 16, 20. Then we connect the dots. And that's our graph. So these are coffees. This is money. I start with $20, but every time I buy a coffee, I have less and less and less and less. And there you go. Some story problem fun.